Awesome. So today we're going to be covering inheritance and encapsulation, so quite an important topic. How can I work this? Sorry, I'm also just figuring out all of these little Zoom things. Huh. Weird. Alright. Okay, we're going to be covering inheritance and encapsulation, so basically just continuing on our study of object-oriented programming. And for this section in the textbook, I should tell you guys that as well. Today we will be starting at the encapsulation first, I think. Yeah. Inheritance. Starting on page 48. That's where you'll find the most information about what you see in the slides, at least. Alright, so yeah, let's just get started. The first thing we're going to have to do is revise a little bit. So we'll start by just setting up an example of a class and just revising what we know about classes. Okay. Wait, can one of you post like a chat message quickly, because I want to see if it's going to overlay over the screen or something. I don't know, it doesn't seem to. That's a bit of a pity. Wait, Bryn, can you tell me, was there a message posted like that?
So I didn't see.
Okay.
I was busy typing, so.
Okay, cool. I don't know, okay, I can't seem to see the messages. That's a bit silly. Like, if you post in chat, it should just bring up a little overlay to show me all the messages, because then I can't see questions otherwise. Okay, but anyway, we'll focus on this. Cool, so let's set up a little example. Yeah, that works nicely. Okay. Okay, so we're going to set up an example of a class. It's going to be a simple one. So we're used to this person class from previous slides where we had like a person, and the person had 3 properties, if you guys recall: height, weight, and hair color. Okay, this time we're going to go for a slightly simpler class. All right, I see someone else joined as well. That's cool. We're going to go for a slightly simpler class. It's only going to have 2 properties. All right, it's only going to have 2 properties. And it's just going to be a rectangle class. Okay, and you can see why a rectangle would only have 2 properties, right? Because we only need a length and a width. Okay, let's see. Okay, because we only need a length and a width. All right, so we'll start by saying class rectangle. Okay, as our usual way of just defining a new class. All right, so nothing new there. We need to define our 2 properties. Okay, so can someone give me some ideas for what you would use to store? Oh, that's cool. I could open up a poll, eh? Should I try that? Add a question. I don't know. Okay, no, this is not working nicely. Okay, you have to log into their main site to add a question. That's a bit weird. Okay, so let's not do that. More. Where's chat? Chat. Yes, okay, that's perfect. They're making cards maybe. Oh, yes, that's a good point, Teddy. They may have been making. Okay, but now I can see the chat while I have the slides on the screen, so that is fantastic. Alright, so can someone give me some tips or a suggestion as to what type our 2 properties for a rectangle would be? So we have a length and a width. How would we store those 2 properties? Yes, Taddy, that's a good point. I see you probably have an open place in your notes where static is. Hey. So yeah, I'll explain static in this method. That'll be a good way to explain it, actually. While we're setting up this method, I'll explain it. So But first, what data types will our two properties have for a rectangle class? Any suggestions? Let's think about this. What types do we know even? Let's just name types generally to get us started as a little warm-up. Okay, someone says double. All right. Okay, double's a good suggestion for a length and a width. What else could we use? Instead of double, I could use, I assume that was supposed to be int. Ints would be a good one to use as well. We could also use float, right? Or short or long. Let's go, I think int or double is forgivable. You could use either. Let's go with double because we haven't seen as many doubles. Okay, but you could use ints. You don't really need to store a decimal place for your length and width. And then we also learned about these two words already, actually. Our properties can be either public or private. Okay, so if I make length and width public, so I go public, we're going to make them double, and then I say length. Okay, like that. Okay, and I say public, double, width. Okay, so I've now got two public properties, right? If I decided, so now because they're public, we know that means I can access them outside the class. I can access them and change them outside the class, right? We know it means that. But if I made them private, so if I went and made length private like this, what two things would I need in order to be able to change and see length from outside of this method? What are the two things that I would need? What are they called? There are two things that I would need in this case if I made it private. What are those two things? Good of you to join us. I'll mark you guys as present on the register during the break, maybe when I'm not sharing my screen, because now this is also recording in the YouTube video, so I don't want to accidentally post your guys' phone numbers and stuff. Okay, someone says right line. That would print it out. Tuddy is on point. Yes, getters and setters. That is correct. So if I made them private, I would need getters and setters. All right. And last week we went through this long way of creating getters and setters, but I've already introduced you to this idea that getters and setters can be created totally automatically, right? Like this, by just saying get set. Okay, so this is just automatically adding our getter, and this is just automatically adding our setter. And now length is private. See, I did change it to a capital L as well, just to make sure things are, we are still following good C# practice. But I'm going to do the same with the width as well. So they're both private now, but I also automatically added their getters and setters. All right, we're happy with that. So we can do that with any variable. Yeah, any property. Yeah, any property or attributes in a class you can do that kind of thing with. Yeah. What are getters and setters? You forgot what getters and setters are. I suppose I can mention. So if we have a private variable, all right, a private variable, the only way, no one told me. We covered it last week a lot. But it's okay. It's okay. I can give you guys a quick refresher. Yes, probably. Okay. So if we have a private variable, okay, what does private mean? It means, but you should have watched the YouTube video as well, right? So if we have a private variable, that would mean that it's only accessible inside the class. Okay, cool. So let me show you that. If you see, I've created here private double length. Okay, private double length. That means our length property is only accessible inside our class. Okay, and I can show you that. So, it's going to ask me to log in. Hey, let me just do this quickly. Sorry about that. There we go. Okay, we're logged in. All right, so I'm going to just redo that quickly. So I'm just going to re-explain what private is for. I imagine it'll be of some benefit for everyone anyway. So we create our class rectangle as we did previously. Okay, quite simple. We then say private double length. So we create a property called length. Okay, and obviously our someone your mic has some background noise because you can. Okay, so private double length. Okay, like that. So this is now a private variable. So what does that mean? So let me show you. So I'll create an object of type rectangle. Okay, and we know how to do that, I hope. We say rectangle. Okay, the name of our object, I'm going to call it rect. You could also call it shape or anything you want, right? S, X, whatever you want to call it. Okay, I'm going to call mine rect. And then you say new rectangle. All right. Okay, new rectangle. So I've created this rectangle object. All right, and that'll work. If I run it, you can see it runs. It doesn't print anything out yet because obviously I haven't told it to, but it runs. All right, that's what matters for now. So, what does this private mean? If I say console or if I say rect dot length, okay, so inside my rect object there is a property called length, and I access that with rect dot length. And if I set that to something, so I set it to like 6, so I'm saying the length of my rectangle is 6. I'll say 6.0 because it's a double, right? It has a decimal. So 6.0. Rect.length equals 6.0. All right? If I run this, it'll break, okay? Because it says rectangle.length is inaccessible due to its protection level. Okay? And we saw this error a lot last week. Okay, rectangle.length is inaccessible due to its protection level. So what is it saying there? It's saying because it's private, you are not allowed to access this from class program. Because you see, I'm accessing rect.length in class program, but it is private to class rectangle. Okay, so the word private means what you think it means. Okay, it's only accessible inside the class. All right. And you can see that that's what's doing it, because if I change it to public double length, you can see this error will go away. All right. It takes some time to run, but the error will go away. You see it runs now. All right. Cool. So when it's private, we need to add something called a getter in order to see it. Okay. And we need to add a setter in order to write to it. So that's all I'm going to say on this topic in this thing, because in this lecture, because we have already covered getters and setters in quite a lot of detail in last week's lecture. Okay, so do go ahead and watch last week's lecture if you're still uncomfortable about getters and setters, all right? But they are a pretty simple concept. So because it's private, it's only accessible inside the class. So we have to create these two public methods, all right? Public methods, get and set, all right? Don't worry, for now, just know, you know that because it's private, we need another way to access it, okay? Or then it gives us that error. And the way we access it is get and set. Okay, for this lecture, if you know that, you'll be okay. If you want more detail, then go watch the YouTube video, because we do have quite a lot to get through today, okay? All right. So we've got getters and setters, all right, for length and width, all right, and they're private variables. For now, you can even just think about it that I've created two properties here. The fact that they're private or public won't have much bearing this early on, all right. Cool. So there was another method that we also learnt about that was used to create a new object. I'm not going to use the actual word we use to describe it when we create a new object, but yeah. So what? Okay, you're very. I didn't even explain fully. That is correct. Okay, it is called a constructor. All right, it is called a constructor. Okay, so what is a constructor? It's Teddy's hacking. It's as the name suggests. Okay, it's as the name suggests. It constructs a new object. Okay, so the constructor allows us to define a way to construct a new object. And you can hear that in the name, right? It's a constructor. It constructs objects. Right? And what is the big rule about constructors? The big rule, well, there's two, actually. They have to be public, obviously, okay, because we have to be able to access our constructor from outside the class, because when we construct objects of this class, obviously we're going to be outside the class, all right? So public, and they have to have the same name as the class. Okay, so you see our class is called rectangle. That means our constructor is also called rectangle. Okay. Now, anyone should be able to get this next question. So, how many variables, how many parameters is this method going to have to take in, accept or expect? How many parameters is this method going to expect in order to create a new rectangle? Okay. Taddy, you can't just answer instantly. Okay. Maybe Taddy must pause for like a head start. Always a good guess, Creflo. So, but no, it is 2. All right. Why is it 2? Taddy, do you want to say maybe why? Why is it that we need 2 variables in order to create a... Why do we need 2 variables in order to construct a rectangle? Why is it 2? Because you use 2. Can you describe that more technically? Like, what are the 2 things that I need to set? Width and length, exactly. Okay, so we have 2 properties, you see? We have 2 properties. So we need to take in 2 variables. How did people get that wrong? Okay, so we need to say double, okay, and we'll say length. So we're going to take in a length, all right, and we can take in a width, all right, double width. Not too bad, right? And then we just, in order to construct a rectangle, all we need to do is set the length and width, right? So length equals length, and width equals width. Okay, and bam, we've created a rectangle. That's how you would create or construct a rectangle. Okay, so hopefully you guys understand that. That was just us revising classes. Okay, so now when I create a rectangle, I have to give it a length and a width. So I'm just going to do that. I'm going to say 10.0 and 3.0. So our length, the length of our rectangle is 10.0. The width of our rectangle is 3.0. Okay. Ooh, semicolon. Where? Oh, right. Yeah, sorry about that. We didn't need semicolons there. Okay. Cool. So that's done. We've now constructed a rectangle with length 10 and length 3. If I wanted to construct another rectangle, I would just copy paste this basically, right? So I can just say Control C, Control V. I'll call this one rect2, and I can just make its length whatever I want and its width whatever I want, and that'll work. Okay, so we can now construct as many rectangles as we want very, very easily. All right. Cool. So that's how classes work. This is nothing new, guys. This is what we covered last week. All right, we haven't actually learned anything new yet. This was just revision. Okay, and we've set up a little example. Now, Teddy did mention, and I did promise last week to explain what the word static means. So I'm going to do that now. Okay, I'm going to do that now, so everyone concentrate. Okay. We also learned about how inside our class, we have 2 things. Okay, we don't just have properties or attributes. Properties and attributes, those are the same. Okay, we don't just have those. We have one other thing. Okay, It was called a method. All right, a method. We have methods as well, right? Our constructor is one method, but we have other methods as well. So I'm going to create a method that calculates the area of a rectangle. How do we calculate the area of a rectangle, guys? How do we calculate the area of a rectangle? Anyone? This is a very simple question, not to do with programming at all. How do we calculate the area of a rectangle? Length times width. Good work. Length times width. Or length times breadth. Yeah, sure. We have width here. We could have called it breadth. Sure. Okay, so we calculate the area with length times width. Okay, guys. Now pay attention, because this will help you understand what methods are doing. All right? You know how to calculate the area of a rectangle. All I am going to do is tell our class how to do that. Okay? So let me just set it up in your head. Okay, we've got this object. Okay, its name is rect. It has an area, a length of 10, and a width of 3. What is its area? You guys know what its area is, right? Tell me what its area is. Its length is 10. Its area is 30. Yes, correct. Okay, its area is 30. So we're going to make a method that when I go rect.area, okay, when I say rect.area, it must return 30. Okay, it must return 30. So how am I going to do that? All right, let's see this. So I say public. Okay, my method's going to be public. All right, what type is dape? Let's see. So I can't write notes on this platform. Damn, you're the fast to chat. I'm still trying to find the damn button. Okay, dape. Maybe you can answer this. That 30 in our code. Okay, in our code, what type will it be? What type is 30? Remember, think about our code. You're saying 10.0 times 3.0. Yeah, what type is it? What type is it, though? Remember, we have variable types like int, double, float. In our case, if you say length times width, okay, 30 without a decimal place is indeed an integer. But look at our code. What is length and what is width? If I multiply them together, what will I get? Look, we create length and width here. We create length and width here. What are they? They're not ints, right? What are they? 30.0. You don't know what type that is. What? Okay, Bryn says float, but guys, keep in mind here, okay? When you say double times double, it's just going to be a double. Okay, if you times a double by a double, it's still going to be a double. Okay. Yeah, precisely. Okay, so what type is our area method going to return? What type is our area method going to return? Okay, we wanted to return 30.0, hey? We wanted to return length times width. So what area... Triple. Okay, I think, yeah, this question is maybe a bit easy. Okay, so it's double. All right, it's going to return a double. All right, and we say area. Okay, public double area. Bam, we've created an area method. Easy peasy. So, yeah, what's up? Okay, so what pages are the types of variables? I think they're page 8 or something, but this is very long ago. They are, let's see, yeah. Okay, page 9. Sorry, page 9, yeah. Oh, Tadi got the page before me. Okay, so we've got this area method. Okay, when will our rectangle be finished? We're going to finish the beginning of this method now. Okay, so public double area. All right, we've got an area method. Okay, guys, what what is this method going to do? It wants to calculate the area, right? So I'm going to say double area equals. What is area going to equals, guys? What is area going to equals? 30.0. No, but I want to calculate that, remember? How do I calculate that with this rectangle? What properties would I be using? What L times B, but Bryn, in the code, what are L and B? What are L and B? We don't say L times... What is L? What is L inside our code? What is the name of the property? Okay. You guys are close, but remember, ours have capital L's. And things in C# are case sensitive. Okay? Capital L is the name of our property. This is our property, and you see it's length with a capital L. So it's going to be length with a capital L times, so asterisk. Good job, L, for getting that it was an asterisk. Okay, it has to be an asterisk. And width also has a capital W. Okay, so width. Okay, like so. So that'll calculate the area, and then I just want to return area. Okay, like so. Now, if I come up here and I say console.writeLine, okay, and I say rect dot, the name of our method, okay, area, with the two little brackets after it, you guys know what's going to happen, right? Prints out 30. Success. Okay. So, I see, I can't even remember. No, Dapper, don't feel discouraged. It's totally fine. Dude, it's totally fine. Okay. We'll figure things out before the end of the year. There's plenty of time, and you guys are doing okay. Don't worry. Okay, so if it's 30 point, yeah, it doesn't print the point 0 if it's yeah, exactly. Okay, cool. So that's a rectangle method. I'm quickly going to explain what static means. Okay, so I'm gonna do this. What isn't? What do you mean what isn't? Oh, that's not fair. Okay. Okay, so let me create another method, and this method is just going to be very silly. Okay, it's just going to print out the phrase I am a rectangle. Okay, that's all this method is going to do. It's going to print out the phrase I am a rectangle. Okay, so public void print, I'm going to call it, or print out. Okay, and all it does is print out console.writeLine I am a rectangle. Okay, let's all subscribe and like. Oh, that would be. I noticed someone was feeling judgy on my Crawford video. Dang, I think I've attracted some people from the Control plus into the code, please. Oh yeah, sure, 100%. Actually, I can make it full screen. I don't know why it hasn't been full screen all this time. And also zoom in, I think. Okay, cool. So, all right. So, guys, please concentrate on this a little bit. It's not difficult to understand what will be going on here. But I do just want you to focus so that I only have to explain it once, because it's not a super important topic that'll come up in tests often. It's just like a silly thing that you should know. Ooh, that is a bit... I mean, you can use that if you want. Please don't troll with it, though. If you post a lesson on YouTube, wouldn't it be free C#? Yes, yeah, it would be. What was that? But you wouldn't be able to write the test at the end of the year, right, Kreflo? So, I mean, you won't be able to get the certificate if you're just randomly watching my YouTube videos. Okay, but anyway, let's focus. Okay, so we've got this little method at the bottom here. If I create a rectangle, right, like this, and I type here rect.printout, okay, where will this go? It'll go inside the object rect, which is a rectangle, right? So it'll go inside this class. It's going to find the method print out, and then it's just going to console.writeLine I am a rectangle. Okay, very simple method, guys. Hopefully you're super comfortable with what that's doing. So if I run this, it just prints out I am a rectangle. All right, it just prints out I am a rectangle. Okay, and you can see by the little arrows that will appear on the screen, if you look down here, it's I am a rectangle. Okay, I am a rectangle. All right. Cool. So that's all this does. Now, this is what, if I say public notice what happened here. I had to create a rectangle in order to say rect.printout. You understand? You see on this line here, I create a rectangle and I say rect.printout. Okay. Let's say I don't create a rectangle and I try to go rectangle.printout. Okay. Rectangle.printout. What happens? If I run this, it says an object reference is required for the non-static field, method, or property rectangle.printout. So you see, you guys know what an object is, right? Rect is an object, and I said rect.printout. Now, this time, I didn't create rect, right? I just ran it and it deleted everything. That's weird. Okay, if I don't, but it might be because it's requiring you to log in, Bryn, if you're working on Rex Tester. But you guys should all create Rex Tester accounts at some point. But let's concentrate, guys. Please concentrate. I don't want to have to explain static again. Okay, so if I say rectangle rect, all right, rect.printout. Okay, it's, you got VS Code. Oh, that's cool. An object reference is required for the non-static field. Okay. Do you understand what that means? It's saying rectangle is not an object, right? It's a class. All right. This method is not static. You can see I don't use the word static. So it requires that an object exists before I access the method. Okay. If I say static here, then, without creating an object, I am able to access the method. Okay, and you see it prints out I am a rectangle. Okay, Tadi, you did ask this. Do you understand what static is doing here? Static allows me to access a method without creating an object. Okay, and everyone else, do you understand what this is doing? If I make something static, then without creating an object, I can access it. If you see, if this was not static, it says an object reference is required for the non-static field. Okay, so then I would have to create an object and say rect, the object.printout, not just the name of the class. That's an interesting way of thinking about it, and if that helps you answer questions about static, then yeah, go for it. But rather think about it like if you can. But actually, that's a good way of viewing it. Actually, yeah, it's a good way of viewing it. But remember, you're not actually creating a getter and setter, right? You're just adding the word. Okay. So static is just what to make a right line work, no matter what. No. It can work with any method. Okay, any method. What it does, if you say something is static, then it does not have to be accessed through an object. Yeah, it does not have to be accessed through an object. Okay. Yeah, I do find it easier to teach through schools than online. But this is quite nice too. Okay. But so you see, I had to create an object of type rectangle to access printout because it is not static. If I try to access it without the object, okay, if I try to access it without the object, so if I just say rectangle, you see I'm not using my object rect anymore. It's going to fail now because it's not static. If I say it's static, then I'm allowed to access it directly without an object. Okay, that's all the word means. That's all it does. Okay. Okay, that's it. So that's just what static does. It's a super simple word, and you don't have to think about it too much. It won't come up often. Okay. Anyway, all right. I think we've. So is it better to use static or? You should create objects generally. I mean, so you can see the main method is static, right? The main method is static because I don't access it with a program object, right? Look, actually, let me show you this. So I'll create a method. Let's just spend some time on it so we make sure we understand it, okay? Public void, I'm going to call the method my method, okay? My method. All right, like that. Okay, and all this is going to print out. It's just going to say console.writeLine, and let's make it say I am not static. Okay, I am not static. All right. Now, if I say my method here, just like this, my method, do you think that will work? Will this print out I am not static? Will it come here and print out I am not static? No, right? Because I haven't created an object. Okay? I haven't created an object, so it gives us an error. All right? In order to make this work, I would have to create an object of type program. Okay, I would have to do this. I'd have to say program prog equals new program. Okay? And then I could say prog dot my method. Okay. Prog for program. It's just shortening it. It's a very typical way of naming. It's a very typical way of naming an object. Okay, you just shorten the. So like it's an object of type program. Okay. Tuddy says object equals property. No. An object, a property is a variable inside a class. Okay, we can spend some more time on this just because it's we want to really get it. Okay, so I'm gonna open last week's slides quickly just to refresh your guys' memory. Okay. How can I do this? Presents. Okay. But we must work a bit quickly, guys, because time is of the essence. Okay, why won't it just let me? Wow, Google Chrome is being a bit weird, hey? If I say Control W or something, I don't know why it's doing that. I can say Control W. Yeah, okay, cool. All right, so we're just in last week's lesson. Right, I'm just going to skip through a lot of this. All right, here, this is the imagery we created. Okay, I'm in 11, so I'm chilling too long. Okay, look, so we've got a class called person. All right, in our case, we have a class called rectangle. Okay. Okay, we've got a class called person. In our case, in our code from today, guys, quiet. I'm please focus because we want you guys to get it. Okay. So we've got a class called person. All right. Class called yeah, watching the chat go is just a bit but yeah, just focus for this, please, because I don't want to have to explain it again. Okay, so we've got a class, it's called person. All right, we today created a class called rectangle. All right, last week we created 3 objects. Okay, person 1, person 2, and person 3. Okay, today we have created 1 object, okay, rect. We just created an object called rect. our person objects, okay, or our person class rather, had 3 attributes. Okay, it had hair color, height, and weight. Okay, which means all of our objects also had a hair color, a height, and a weight. Okay, today, with our rectangle class, it has 2 properties. Okay, it has 2 properties. Right? Our rectangle class has 2 properties. It just has length and width. Okay. So, objects are these whole things, right? Like person 2 is an object. Okay, person 2 is an object. Person 1 is an object. Person 3 is an object. Okay. Properties are these individual things like height, hair color, weight. Okay. Person 1 dot height. Okay. Height here is a property in the class. Okay. Hair color is a property. Weight is a property. Okay. So these are what objects are. You can see like an object is... Yeah, it's an attribute. Yeah, property is an attribute. It's not... Okay, cool. But as long as you understand the difference between an object and a property, okay? Like, an object is something like person 2 or person 1. It's like one entire type of class, okay? So it's like a... Okay, that was maybe a bit of a bad way of putting it. But it's one instance of a class, okay? It's... So an object will have all the properties that the class it is a type of has. Okay, so our person class had a hair color, a height, and a weight. So person 2, which is an object of type person, has a weight, a height, and a hair color. Okay. All right. So that's it. Okay, that's the difference between objects and properties. Okay, so I just wanted to go over that quickly. So here, length and width are properties. Okay, a whole rectangle, rect, with a length of 10 and a width of 3, this is an object. Okay. Anyway, all right. That, I think, is enough revision of last week. We do definitely need to get started on this week's content. Okay. All right. Guys, you can't see the chat open on my screen, right? You can't see the chat open on my screen, so... Oh, you can. Oh, that's annoying. Okay, I'm just going to leave it in the middle then for now, alright? So that you can see... Okay, cool. So, look, we've got four things here. Okay. Inheritance, polymorphism, interfaces, encapsulation. So forgive me for what I'm about to do. Okay. So, guys, these are... So a property attribute is what the thing has. So yeah, exactly. What the object has. Exactly. Okay. Anyway. Okay, so look. Guys, focus. So we've got these 4 ideas here. Alright? Now they sound quite scary, I can imagine. They sound quite scary. But we're only going to think about 3 of them today. And you already know what encapsulation is. As scary as it sounds, you already know what this is, actually. So these 2 new words, well, you'll learn 3 new words today. Okay, inheritance, polymorphism, and encapsulation. But you already know the meaning of encapsulation, basically. So I'm going to start by explaining inheritance, okay? And you'll see that it's actually quite nicely named. All right, it might sound scary now, but it's actually quite nicely named. Okay. So it basically means what you think it means. All right. So let's start covering this concept of inheritance, and let's see if you guys can get it. All right. Let's see if you guys can get it. So, inheritance as I said, it means what it sounds like. Okay, it means what it does in the real world. Right? Classes can inherit from other classes. So what do you think I mean when I say that? So just like you can inherit traits from your parents. So for example, if your parent has like brown hair, you might also have brown hair, right? Not necessarily, but you could. Okay, you can inherit certain traits from your parents, and classes can do the same thing. Okay, remember what I'm saying here. A class can get properties. I'm not saying object. Okay, I'm not saying object. Objects will not inherit from each other. Okay, classes can inherit from each other. Okay, so like, and it means what you think it means. It means it can inherit properties, but also methods. Okay, anything a class has, it could inherit from another class. Okay, so let's think about some examples here, right? Like last week we thought about this person class. Okay, and we said a person has a hair color, or an object of type person has a hair color, a weight, and a height. Okay, so the person class had these three properties. Okay, not too bad. That's just what we revised, right? If I said doctor person, okay, like this, this is saying the doctor class inherits from the person class. Okay, so what this would mean is that the doctor also has a height, a weight, and a hair color. We haven't set them. We haven't created an object here. Okay, we have not created an object of type doctor. This is just saying that the class doctor, because it inherits from person, it already has a height, a weight, and a hair color. Okay, it can have a bunch of other things as well. All right, but at least because it inherits from this class, it would have all the properties that this class has and all the methods that this class has. Okay, and again, I could say something like nurse person. Okay, this would say that, okay, so doctor inherits from person, but nurse also inherits from person. Okay, so a nurse would have a weight, a height, and a hair color as well. It can have a bunch of other things as well. A nurse could have a bunch of other things as well. But at least it's going to have those properties from person. Okay, but we can go through another example in case this isn't making sense yet. I'm just going to put the chat over here. You already see that's just doctor person inheriting. Okay, I'm just going to move these things aside because we're going to have the other example on this side of the screen now. Okay, polygon. Okay, what's a polygon? It's like a multi-sided shape, right? Polygon is a multi-sided shape. A polygon might have like a length, a width, a number of sides, any number of properties, really. Okay. We can agree, though, that a rectangle is a special type of polygon, right? It has 4 sides, and the length and width are not equal. Okay, that's what we might say a rectangle is. So a polygon might have like a length and a width, but a rectangle also has a length and a width. Okay, so how might we display this in C#? We would say square polygon or rectangle polygon. Okay, this one in particular. Okay, so we would say a rectangle has a length and a width. Okay, it inherits that length and width from polygon. Okay, so polygon defines a length and a width. Basically, actually, in a way. Oh, give me a with 2. Okay, yeah, what's up, Bryn? I don't know if you were raising your hand to ask a question or... Okay, no props. Okay, so, polygon. Okay, so we can define this class polygon. It can have any properties, okay? A rectangle inheriting from polygon, all that means is, and you can picture this in your head, guys. I want you to picture it in your head. It makes sense. A rectangle is a type of polygon. Okay, a square is a type of polygon. Okay, they're different, but both of them have a length and a width, and both of them could have a way to calculate their area, right? Both of them could do this. Okay, so yeah, let me show you this in code because it might make more sense that way. Okay, so the polygon itself becomes a class. Yeah, exactly. So we define a polygon class like we defined a person class. Okay, we'll define these two classes. All right, and then we're going to create a square and a rectangle, both of which inherit from polygon. Okay. Yeah, exactly. You could do it with cars as well, right? You could define a car class, and then you could say Mercedes inherit from car, and Ferrari inherit from car. Okay, you could do that. And then you only have to define car once, and from it you can get both like Ferraris and Mercedes, for example. Okay, but let's rather stick with the example that we've already programmed up here. Okay. Yeah. But remember, Tadi, now we're talking about inheritance, hey? So now we wouldn't create the Mercedes as an object. Okay. We would inherit. It would be another class, and we would have a bunch of Mercedes objects. All right. But now, yeah, let's focus. Okay, so we've got our rectangle class here. Okay. What I want to do now is, instead of creating rectangle directly, I want to create a polygon. Okay, I want to create a polygon. Yeah, exactly. They both have a length and a width, that bit, to be more specific. They both have, in our case, a rectangle has a length and a width, and it has a way to calculate the area. And all we're going to do is say, okay, we're going to create a polygon that has a length, a width, and a way to calculate the area. And then instead of defining all of this stuff in rectangle, we're just going to inherit it from polygon. Okay, so let me show you how we'll do that. Okay, how we'll do that is we'll create a new class, right? We need another class. Okay, so we'll have to say class polygon, like so. Okay, exactly like we created the rectangle class. All right, so we've got class rectangle, we've got class polygon. You can see that here. Okay, class polygon is here. It's empty currently, and we've got class rectangle here. Okay, so what am I going to do? I'm going to take the length and width properties from rectangle. So I control X, I cut them. I'm going to put them in polygon instead. Okay, so I just put them down here. Length and width, or up here rather. See here. So now polygons have length and width. Okay, you see now our rectangle doesn't have a length or width property, right? The rectangle currently doesn't have a length or width property, and I'm going to do the same exact thing with area. I'm just going to control X, remove it entirely from rectangle, and I'm just going to put it down in polygon here, okay, like so. You see? So now you see our rectangle doesn't have a length or a width, and it doesn't have a way to calculate the area. Okay. All it has is a constructor. All right. So let me just set up our little example again. I say console.writeLine rect.area. Okay, something like that. Now, when I run this, it'll obviously break currently, as Tadi pointed out. Why would it break? Because now, so we are saying that the polygon has the same length. No. We're saying that it does have a length and a width. So look, Dape, this is an important thing to get. So you're on a good track here. So just concentrate on what I'm about to say. Okay. So look, break time literally. Yes. Good point, Tadi. Okay, we'll take a break just now. But wait, Dape, concentrate quickly. Okay. Look, so rectangles, the rectangle class or the polygon class, okay? We never tell them exactly what their length and width are. Okay? Look, I never specify a number here. All right. All I'm saying is, look, it has a length, that's a double. It has a width, that's a double. Okay. I never specify what that length and width are. The only time I do is when I create an object. Okay. Objects have specific values. So classes just have properties. All the class is saying is, look, polygons have a length. Okay. Polygons have a length. I'm not telling you what they are. They just have a length. All right? When you create an object of a class, yes, exactly. They have the same properties. We haven't told it this yet. So guys, just bear with me for like 4 more minutes and then we'll take a break. Okay? So we haven't told it this yet now, right? So when I run this, it says the name length does not exist in the current context. Okay? So what this is saying is rectangles, here where I say length equals length, what this is saying is rectangles don't have a length. What is it supposed to do? How do I fix that? I say colon polygon. Okay. So what has happened here? What I've done is I've said all rectangles, okay, all rectangles, the class rectangle inherits from polygon. So it's going to go to polygon. It's going to see that polygons have length, widths, and a method to calculate the area. And it's going to say, okay, a rectangle has all of that, and it has a constructor. Okay. Ooh, sorry, due to its protection level. Oh, right. Let me just make these public for now, I guess. Or should I do that? Yeah, I'm just going to make it public for now, okay? Because I don't want to have to fix this now, rather. Okay, so we're just going to make that public. Oof, I have to change quite a bit. Okay, that should work now, I'm hoping, rather than... Yeah. Okay, you see, now it works again, guys. It works again now. Okay. Yeah, exactly. So classes define a general type. Okay, a general type. So it'll just have a property. We don't set it yet. And when we create an object, we can set that property. We don't always have to. We don't always have to set the property. How we tell it what to set and what not to set and what to set those things to is a constructor. Okay, is a constructor. But yeah, that's correct. Good understanding. All right. Let's take a... we have spent a lot of time. You have been... What? What is going on? Are you guys still here? I don't know. It's a bit weird. Yeah, okay. For some reason, Zoom just decided to sign me out. Whatever. Okay, cool. I think, yeah, let's take a break. Should we do sort of 8 minutes, maybe? 8 minutes? Okay, so we'll come back at 3:12. Okay, 15:12. Yeah. But no, it's good, guys. But do try to help each other and feel free to ask questions. Obviously, we have to get through the content before the end of the year. So I have to speed through some things. But yeah, like feel free to help each other. And yeah, just remember that the YouTube videos are there. Don't panic too much, okay? By the end of the year, you guys will be fine, I'm sure. Okay, cool. All right, yeah, so we're on break now, guys. You can go get some water, go to the bathroom. But yeah, 15:12. Okay, I'm going to start exactly at 15:12. Okay. 2 more minutes. Yeah, hopefully we can get some of these other ideas. That's actually a good plan, to just cover up the name of the slides, because I remember one of the slides being a bit weirdly named. Although that covers the code as well. Not the best idea. Subnautica is the greatest game, sheesh. But refocus. 1 more minute. Cool. Let's get started again. Sorry guys, we must. Alright, so look, we've got this example, alright? We've now, what have we done? We've created a rectangle, okay? We've also created a polygon. The polygon defines the length, the width, and a method to calculate the area, okay? The rectangle inherits the length, the width, and the method to calculate the area, and adds on a constructor, okay, to create rectangles. So let's look at this, right? Okay, guys, pay attention. So we've got a class polygon, all right? We define a length and a width property. You guys see that? We say public double area, okay? This defines a method to calculate the area of a polygon, okay? It just takes the length multiplied by the width, okay? So this is all a polygon is. It has no constructor, okay? So it won't automatically set the length and the width if we created a polygon object, okay? It has no constructor. It does not know how to automatically create a polygon, okay? But that's fine, because when we create rectangle, we say, all right, rectangle inherits, that's what this colon is saying, from polygon. So what does it inherit? It inherits the two properties, length and width, and it inherits the method area. Okay. So when I come to rectangle and I create this constructor and I say length equals length and width equals width, it knows what length and width are, because it's inherited them from polygon. All right. Also, when I say rect.area, it knows what area is, because this rectangle class that rect is inherited this area method from polygon. So it knows what rect.area does. All right, guys, I hope you get that, what we've created so far. What I want to show you now is this exact structure in the slides, okay, inside code. So we created a polygon. We've got a rectangle that inherits from polygon. Now, what about a square? What about a square? Okay. Let's create class square. Okay, so we'll say class square. Okay, but now like in rectangle, we don't have to define length and width again, right? It's already defined in polygon. So all we'll say is square inherits from polygon, like so. Okay. But what will be the difference here, guys? How many, if I create a square constructor like this, like so, square, okay, like so, how many parameters will square have to take in? Rectangle had to take in a length and width. How many parameters will square have to take in? How many do we need to create a square? Just one, right? Why do we only need one? Why do we only need one? Yeah, lengths, they're all equal, exactly. So if I just take in a length, then I can just say length equals length and width equals length, right? Because they're the same. So my square constructor just has to take in double length, for example. Okay? And then I just say this dot length equals length and this dot width equals length. All right, like so. Not too bad, right? And so now, from the same polygon class, I have defined both a rectangle and a square, and they are different. Okay, squares only take in one parameter. These two classes are fundamentally different. A square could only ever have the same length and width. Well, from the constructor. Okay, we could manually change it technically because we haven't put in security, but that's fine. Okay, for now. All right. So I hope you guys see like the power that this structure has. Okay. Oof, my back is sore. Yeah, exactly. It makes life easy, but I also want to show you just how clever it is, okay? Because it's not just that we've defined it this way for convenience. C# knows what these things mean. Okay, so actually I'm going to show you that. So we've created a rectangle. Okay, I want to create a square now, right? So to do that, I just need to say square. I'm going to call my square SQR. Okay, or actually, yeah, to show you that it doesn't matter, I'm going to call it Ferrari. Okay, square Ferrari. My square is called Ferrari, and I'll say new square. Okay, and I only need to give it one number this time, right? So I'm just going to say 8.0. Okay, it's just 8.0. Okay, square Ferrari. Well, I want to show you guys because a lot of students will think that like, oh, rectangle rect, it has to be a lowercase version, the first 4 letters, you know. So now, and this also got your attention, so it worked. Okay, square Ferrari equals new square. So our square object, its name is Ferrari, and it's, ooh, I spelled square wrong in the second one here though, so that wouldn't work. There we go. So we have this new object square, and it's called Ferrari, and it has a length of 8, a length and width of 8. Okay, and now you can see if I say console.writeLine Ferrari dot area, it's going to calculate the area of the Ferrari square, right? Even though, see, 64, 8 times 8, even though I didn't define area in square, right? It also just inherited it from polygon. Okay, so it's quite clever. But what I want to show you guys is also how powerful it is for C# to actually understand this. Yeah, you can change their values, yeah. Because remember, the object has a pointer to the length. Okay. Yeah, you see, here I set the length and the width to 8.0, right? I can also just say rect dot width equals 20. That'll work. It's inherited the whole property. It's inherited everything. Okay, it works exactly the same. Okay, exactly the same. All right. Cool. But what I want to show you guys is how clever this is of C#. Okay, how clever this is. And to do that, I'm gonna introduce a new operator to you. Okay, I'm gonna introduce a new operator to you. All right. And that operator is called is. Do you remember all of these operators, guys? Like equals equals, greater than or equal to, right? Greater than is an operator. Okay. All of these things. You remember all these operators? Okay. What was an operator? It has something on the left and something on the right. Right? So is also an operator. It takes something on the left and something on the right. It has two arguments. Okay? An argument on the left and the argument on the right. All right? And what I want to show you, console.writeLine. Okay, like this. Okay? So we've got is. All right. I give this an argument on the left, okay? Something on the left and something on the right, just like a lot of our other operators, right? Except like the ternary operator had 3 arguments, you remember. Plus plus and minus minus have 1. But this is like equals equals and stuff like that. It has 2 arguments, one on the left and one on the right. Okay. This operator though is quite special. Okay, I can, let me see. How do I mute someone? Wow, we have a lot of people here today, actually. Okay, look, we have 2. Yeah, Bryn, mute your mic, please. We've got two arguments here, guys. Oh, let me. Oh, I can do that. There we go. Done. All right. Cool. Look, oh, it unmuted again. Yeah, that's me in that bit. Okay. Cool. Guys, focus though. Is. The word is. Okay, it has something on the left and something on the right. Okay, something on the left and something on the right. Now, this operator is quite special, okay? If you give it something on the left, let's do a simple example first. If I say int x equals 6, okay? You see x is a variable. It's of type int. Okay? If I say x is int, okay? X is int. This will print out true. It's no problem. It's no problem. Okay, this will print out true. Okay, like so. What is happening here? What this is operator does is if you give it a thing on the left, okay, and that thing has the same type as the type you specify on the right, then this operator returns true. Okay, do you guys get that? So you see x is an integer. Yeah, it's an operator. True, it'll return true or false. Well, some operators don't return true or false, but it's like equals equals, greater than or equals to. Yeah, a lot of those operators. Okay, a lot of the ones we learned earlier, just like that, it will return true or false. Okay, binary. So it's again, yeah, it's asking a question. What this is operator asks is the thing on the left the same type as the thing on the right? Is this true? X is int. Is that a true statement? Yes. Okay, because you see x is of type int. If I say x is string, this will return false now, right? And if I run this, you can see it prints out false when it eventually runs. There, false. Okay, so you see, because x is not a string, right? X is string. This is a false statement. X is int. Okay. So you see that. This is what the is operator does. You give it an argument on the left. If that argument has the same type that you specify on the right, it'll return true. Otherwise, it returns false. Yeah, basically. Well, it returns a Boolean. Yeah, true or false. Okay. But now, what I want to show you guys, what's quite cool about this thing that we've done here, this inheritance. Okay, that's what I want to show you. Look, we've got this rect object, right? And it's of type rectangle. You guys see that? Rectangle rect. So we've got a rect object of type rectangle. If I say rect is rectangle, yeah, is needs to be in the middle. Yeah, it's something on the left, something on the right, like all our operators, okay? Like greater than, all of these things, okay? Rect is rectangle, okay? You see rect is rectangle. So this returns true. Yeah, this returns true. Okay, why? Because rect is an object of type rectangle. But now what's very cool, so now I'll show you. If I say rect is square, this returns false now, right? False. Okay, you see that. Returns false. So what we've basically programmed C# to know now is it now knows that rectangles are not squares. Okay. You might think that's like so trivial, but in code, that's quite difficult for a computer to understand, as you can see, right? It's quite a lot of code. But now it understands something even more powerful than that, okay? Because if I say rect is polygon, rect is polygon, this returns true. Okay, you see. So now it knows that all rectangles are polygons. Okay. This is quite a powerful thing for the computer to understand. That's what I want to see. That's what I want to show you, I mean. See you. Okay, so and we can see this with squares as well. So Ferrari is square. Okay. This is a true statement. Our Ferrari object is a square. Okay. And it says true. Okay. It says true. If I say Ferrari is rectangle, Ferrari is rectangle, this will say false. But if I say Ferrari is polygon, it knows that that's true. Okay. Maybe could I don't want to do that. So yeah, cool. So Ferrari is polygon. Okay. You see what it's doing there? It's quite clever, hey? Quite clever. Yeah. Yeah, big PC brain. Okay, so it now knows squares are polygons, rectangles are polygons, but rectangles are not squares. Okay, so it really understands this relationship, and that's just what I wanted to show you with this. Okay. Right. That is inheritance, guys. That's the entire concept. Okay, so all it's saying is that rectangles, or not rectangles, we're not talking about rectangles specifically, obviously, but it's saying that classes can inherit from other classes. Okay, but we now need to learn a few new words. Okay, we just have to learn a few new words. In order to teach you some of these words, I'm going to create another object here. Okay, so we have a rectangle rect, a square Ferrari. I want to create a polygon object as well. Okay, polygon shape equals new polygon. Okay, polygon does not have a constructor. Okay, so I can't specify any parameters. Okay, so length and width initially, shape, our shape object of type polygon, has no specified length and width. Okay, length and width are just not specified. Yeah, it definitely. Everything's going to go on YouTube always. Okay. So, and also all of this code I'm sharing with you through a link on WhatsApp. All of this code will be shared with you. Okay. Hi YouTube. Okay. Yeah. To all 6 views that the video will get. Okay. But look. All right. I've created now 3 objects. Okay. Polygon shape, rectangle rect, and square Ferrari. Okay. So we've got three objects. So I would just want you to guys to understand where this example is in order to explain these new words to you. Okay. Cool. So guys, note this down because if you want to find it again, so in your textbook, all of this will be mentioned between pages 48 and sort of 52. But to be honest, I think you probably don't want to go through this book. Okay. So just note this down. Okay. Note this somewhere down in your textbook or somewhere, these words that I'm about to tell you. Okay. Or just remember them. They should be quite easy to remember. Class polygon. Okay. This class is inherited from, okay, by rectangle and square. Okay, rectangle inherits from polygon and square inherits from polygon. Okay. What we call polygon is a base class. Okay. So if you see the phrase base class, then what that means is this is a class that other classes inherit from. Okay. Now you can see rectangle and square are not base classes, right? Square inherits from polygon, rectangle inherits from polygon. Nothing inherits from rectangle or square. Okay, and there's no other class that inherits from these two things. Rectangle and square are not a base class, are not base classes. We call classes that inherit from other classes derived classes. Okay, I want you to picture this in your head a little bit, what these words are saying. Polygon, because other classes inherit from it, is called a base class, right? It's the base level. Okay? All these other classes can inherit from the base class. Okay? What we could say is rectangle is derived from this other class. And what we mean by that is it sort of extends it, or it takes certain things from it. Okay? Or it's a version of it, all right, in a way. So what we would call rectangle is a derived class. Okay, rectangle is derived from polygon. Okay, square is derived from polygon. Polygon is a base class. Okay, so I'm just introducing all these phrases and words to you because these could come up in tests. Okay, and I'm going to start using those from now on. Okay. So polygon is our base class, and rectangle and square are our derived classes in this case. Okay, cool. One more time, guys. Polygon, because other classes inherit from it, we could call polygon a base class, okay, because it is the base level. It's like a foundation. Okay, it's like a foundation. Rectangle and square inherit from our base class, polygon, right? Inherit from our base class, polygon. So we could call rectangle and square derived classes. Okay. So classes that inherit from other classes are called derived classes. A class that is inherited from is called a base class. Okay. Those are just the two phrases I wanted to introduce you to. And now we can go into two other words about inheritance, okay? And also introduce this other concept as well, all right? Polymorphism. But for now, ignore this word. Okay, ignore this word polymorphism for now. Pretend it's not there. Okay. Cool. So there's two new words I want to introduce you to. But I want to first explain why these words are needed. Okay? The two words are abstract and sealed. Okay? And these two words apply to inheritance. Okay? They apply to inheritance, abstract and sealed. Why do we need these two words? Okay. Let me explain it to you in this way. All right? we have now a class called polygon. Okay. It is a base class. It is defining the concept of a polygon. Okay, it's saying that this has a length and a width and a way to calculate the area. Okay, that's what this base class polygon is doing. But notice, currently, I am allowed to create objects of type polygon. Okay, sealed, S-E-A-L-E-D. Okay, but we'll get into that now. Let's understand why these words need to exist. Okay, so we have polygon shape new polygon. I've created an object of type polygon. Okay, but it is possible as a programmer that I want to define a class that you cannot create an object of. Okay, hopefully you guys get what I just said. So you see I've got this class polygon, and the reason I created it is because I wanted rectangles and squares to derive from that class, right? I wanted the derived classes, rectangle and square, to inherit from the base class polygon, right? I wanted polygon, if you like, I'm going to use this word. I wanted polygon to define an abstract idea. Okay, an abstract idea. I didn't want you to be able to directly go and create something of type polygon. Okay, polygons in this code, I wanted to just be an idea. I wanted to go like, look, rectangles are polygons and squares are polygons. This class polygon defines a relationship. I don't want you to use it to define objects. Okay, rectangles and squares you can use to create objects. Okay, you can create an object of type square and an object of type rectangle. But what if I don't necessarily want you to be able to do this? I don't want you to be able to create a polygon directly. Likewise, currently, I could do something like this. I could say like class circle inherits from square. Right? Currently, I could do something like this. So now, if I created an object of type circle, okay, in C#, now in this code, and I said circle is square, C# would tell me true. Okay, you see why that's not okay, right? That's not a good idea, right? So you see what I'm setting up here is that we need 2 extra ideas. What I want to be able to do is to make it so that you can only inherit from some classes and cannot at all inherit from other classes. Okay, if that doesn't make sense yet, don't worry. The slide should explain it much better. Okay, I just wanted to get through why we need these 2 words. Okay, but let's go through this now. Okay, so abstract and sealed. Okay. So I'm setting up a little bit of an example here, all right? We've got polygon, rectangle, polygon. Okay, polygon, rectangle, polygon. Okay. So look, we've got this polygon class, and we've got a rectangle class that inherits from polygon. In our example, we also have a square, but I don't want you to worry about that for now. Okay. But hopefully you guys recognize this. Okay, polygon, rectangle, polygon. Let's see, Taddy. Let's see. Yes is the short answer, but let's the graphic will explain it quite well. Okay. Currently, in our example, you've seen this. I have a polygon class, and on that first line where I say polygon shape equals new polygon, I create a polygon object. So I have this polygon class, but I'm also allowed to create a polygon object. Okay. I also have a rectangle class that inherits from polygon. Okay. and I'm allowed to create a rectangle object, right? I said rectangle rect equals new rectangle, okay? So I can create this rectangle object. You guys get this? So that's what this is saying. You can create polygon objects directly in our example. There's a polygon class. There's a rectangle class that inherits from polygon, and you can create rectangle objects directly. And what I want to see is if we make polygon abstract or sealed, what would change about this example? Okay. So let's see that now. Okay. So if we make polygon abstract, what that would mean is that this line here is no longer allowed. Okay. You would no longer be allowed to create a polygon object. You would only be allowed to inherit from polygon. So if we said abstract class polygon, that first line, polygon shape equals new polygon, would not be allowed. Okay? So that's all abstract does. It allows us to make this not allowed. It allows us to ban this action. Okay, it allows us to ban this. Okay. If we made polygon sealed, so we said sealed class polygon, okay, so we applied sealed to polygon, then that would ban this action, okay, it would ban this. You would no longer be allowed to inherit from polygon, okay, if polygon was sealed. Okay. Yeah, it allows you to make this not allowed. Okay. Yeah, that. Okay, it allows you to ban this action. Okay, so polygon, if you made it sealed, then you would not be allowed to inherit from polygon. Okay, so this would then become impossible. Okay. So that's what this word abstract and sealed do. Okay, that's what these words mean. Oh no. You're going to have to watch the YouTube video, Kreflo. Cool. Alright. We did take maybe a bit too short of a break, but it's because we do have a lot to get through, guys. We have a lot to get through. Alright. So what I want to show you now is basically this exact thing, except in the code. Okay. So look. Let's start with this first example, all right? I'm going to make polygon, the polygon class, abstract. Okay, I'm going to make the polygon class abstract, all right? So currently, it is not abstract, you see? It's just class polygon, and I can do this. You see, when I run this code, it works, all right? It allows me to create polygon shape equals new polygon. It allows me to create a polygon object. And it allows me to inherit from polygon and create rectangles and squares. All right? If I come here and I say abstract class polygon, okay, abstract class polygon. So I've now made polygon abstract. You see when I run this now, it says error, and what it says is cannot create an instance of the abstract class or interface polygon. Okay, what does that mean? The important bit here that we understand, hopefully, is cannot create an instance of polygon. Okay, this line here, because polygon is abstract, this line here is not allowed. Okay, I am not allowed to create an object of type polygon because polygon is an abstract concept. Okay, it cannot define actual objects. All right, it is an abstract concept. It can only be used as a base class. You are allowed to inherit from it, but now that it is abstract, you cannot create it directly. So if I comment out this line, so it makes this line is no longer code, it just sees it as nothing. And then I run this, you can see the error goes away, and it still allows rectangles to inherit from polygons and squares to inherit from polygon. and the rest is still allowed. Okay, but you are just no longer allowed to create an object of an abstract class directly. Okay, so that's all abstract means. Yeah, you can inherit from the class, but you cannot create objects of the class. So in a way you could say it's indirect, but it's even less direct than indirect. even more indirect than indirect. Okay. Because you are not ever creating an object directly. Okay. Who's the second study? Oh, that's interesting. All right. Cool. Guys, you understand what abstract does? Okay. Let's see this second idea. Okay. Let's try making polygon sealed. Let's try making polygon sealed. All right. Polygon is now going to be sealed. Okay. This will obviously break our whole example, right? So if I say sealed, like so, okay. So we have this idea sealed. Don't worry too much. They aren't commenting or anything, right? Oh, he is. Oh wait, and it's a Taddy with a capital T as well, so I can't tell who's who. Huh, crazy. Wait, 13. That's a lot, eh? From our usual. I guess people like Zoom more. Okay. Anyway. Please, okay, guys, there's only 13 minutes left, so let's just push through this last bit, even though we've now got pretenders in our midst. Okay, so, guys, look, I'm now made polygon sealed. All right, I've now made polygon sealed. So when I run this, you can see it says square cannot derive from sealed type, rectangle cannot derive from sealed type. Okay. Square cannot derive from sealed type polygon. Rectangle cannot derive from sealed type polygon. Okay. But you don't have to worry about it too much, because the real Taddy knows the answer to all of the questions, knows the answers to all of the questions that I'll be asking. So that's how we'll know who the real one is. We don't have to do all of this fancy stuff. Okay. Cool. Anyway. So, square cannot derive from sealed type polygon. Rectangle cannot derive from sealed type polygon. Do you understand what this word sealed is doing, guys? You understand what this word sealed is doing? It's making it so that we cannot inherit from polygon. Yes, it bans inheritance. There we go. That's it. Yeah, sealed bans inheritance. Okay, you're still allowed to create objects directly, though. Okay. So, guys, let's think about how we would define this example ideally. Ideally, we would say abstract class polygon. Okay. Abstract class polygon. And we would say sealed class rectangle and sealed class square. Okay. Sealed class square. I'm the real Taddy. Okay. Oh, yeah, and this we would no longer be able to do because it's abstract, of course. Yeah, but hopefully you guys understand. You should understand every word in this code. Okay. Can you have a sealed abstract class? No, that wouldn't make sense, because then you wouldn't be able to inherit from it or create objects of it directly. It would be a pointless class, wouldn't it? I'm not sure if C would totally ban it. We could see. Let me comment out square here. Let's see if we make it an abstract sealed class square. I don't think this will work. Yeah. It cannot be sealed and abstract. Okay. Because it wouldn't do anything. Okay. Obviously it wouldn't do anything. You wouldn't be able to do anything with it. But also just confirming C# won't even allow it. Okay. Cool. So that's it, guys. That's it for inheritance. Okay. So what do we need to know? Inheritance, abstract, sealed. Okay. I want you to know what all three of those words mean. No, you just can't inherit from it anymore. It makes sense to... I gave that little example about why you wouldn't necessarily want people to inherit from square. Right? You could think like we've got this abstract level with abstract classes, okay? And we inherit from those abstract classes, but eventually we might get to a place where we have a class that is fully defined. We don't want you to be able to extend this class or inherit from this class. It is the last thing. It's just to create objects, okay? Like there's nothing more you could add to it or say about it, okay? Then we would make it sealed and just say, look, you're not allowed to inherit from this. So it's just security. It allows you to make things more secure. Okay. You get me. So in this case, I wouldn't necessarily want you to be able to inherit from class rectangle, right? So I might say it's sealed because rectangle, what would inherit from a rectangle? Like how would you be more specific about what a rectangle is? So I don't want you to be able to inherit from rectangles, so I just say it's sealed. Okay, so it's just for a little bit of extra security. All right. Cool. I think that's it for inheritance. The next topic we were gonna... polymorphism. All right. Okay. Polymorphism sounds like a scary word. Okay, yeah, we have 8 minutes left. I think we can actually get through it though. Okay, because there's only 2 more words that polymorphism requires us to learn. I am not sure if you guys will take it in properly though. So actually, yeah, let's call it there pretty much, but I'll tell you what polymorphism means. Okay, polymorphism, it's Greek. Okay, poly means many. Okay, exactly like polygon is many sides or something like that, many shape. Okay, poly means many. Morphism means forms. Okay, so polymorphism means many forms. Yeah, I will. Polymorphism means many forms. Okay, now there's a tuddy too. Polymorphism is the ability of an object to take on many forms. No, not an object. The ability of properties and methods, particularly methods. Just think about methods. The ability for methods inside classes to take on many different forms. Okay. So area, this area method, using polymorphism, we could make area, so we can say all polygons have a method called area that calculates the area of the polygon. Okay, so we can define that kind of abstract idea. We can say all polygons must have an area method. Okay, and using polymorphism, we can go through all of our polygons. And so by defining this abstract idea of area inside polygon, we said all polygons, everything that inherits from polygon, must have an area method. Okay, so for example, if we defined a triangle, you calculate the area of a triangle in a different way to calculating the area of a rectangle, right? They're both polygons though. Right? So we could say this area method can take on many different forms in all of the classes that inherit from polygon. Okay? So area can take on one form for rectangles, can take on a different form for squares. For example, our area method here might say length times width. Our area method inside the square could say length times length, because that would just work equally as well, right? So this area method, rather than defining it here and just leaving it and just saying, look, this is what area is for everything that inherits from polygon, instead of doing this, we could say, actually, in rectangles, we calculate the area like this, and in squares, we calculate the area like this, and in all our other polygons, we calculate the area in a certain way. Okay, so that's what this concept of polymorphism allows us to do. It allows us to take a method and change it slightly for all of these different use cases. Okay, all of these different scenarios. That's what polymorphism would allow us to do. Anyway, yeah, we only have 4 minutes, so I can't actually explain polymorphism. Okay, so we'll say this is a revision lecture for classes and covering inheritance. Okay, so that's what we'll say. We covered this lecture, and next lecture we'll very quickly go through polymorphism, encapsulation, and start the next section. Okay. All right. So guys, I will share this code with you. So I'm just going to save it quickly. We'll call this inheritance. Everyone can see, only me can edit. Yeah. Wait, but I also have to specify where I save it, don't I? No, it'll just save. Okay. Cool. That's the link for it. I'll send that on the WhatsApp group. Okay, so you'll be able to access this code and play with it yourself. All right. Anyway, yeah, guys, I think we can call it there. Let me stop sharing. Okay. Cool. Cheers, everybody. Yeah, see ya. Cool. Are you playing GTA 5? Cool. Cheers, everybody. See you next week. We'll do Monday again next week, probably. But I'll let you guys know on the WhatsApp group, and I'll upload this all to YouTube so that you can watch it there as well. Okay. Cheers, guys.